So now we come to a more difficult question. This question is difficult because it forces me to use resistance from the start, because you'll notice the only thing I know is resistance. So I'm going to have to find my total resistance. Now, this isn't hard. I just have to remember what I'm doing. These three are in parallel. So I'm going to start by finding the resistance of the parallel section. So that parallel section, I'm going to have to use the resistance equation for parallel. So 1 over the total will be 1 over 6 plus 1 over 2 plus 1 over 6. And I should get something pretty small when I do this. So remember how I've been doing it is I'm going to type it in my calculator. I'm going to go 1 divided by 6 plus 1 divided by 2 plus 1 divided by 6, hit equals so I get my decimal, and then invert it. So I'll invert it and I get 1.2 ohms. Very logical number because remember it should be smaller than all the individual resistances because of that reduction. So when I go to do this, I am going to put that. Oh, I'm not done yet. What am I doing? I now can use this because I also have this guy. This guy is in series with everything else. Everything has to pass through it. So to get my total resistance, my actual total resistance, what I have to do is now take my 1.2, add my 2.8, and that will give me 4. So 4 ohms of resistance in total. That's very logical. So I'm going to put that down here. Now this lets me do some pretty easy stuff, right? Because now I can here use V equals IR. This will let me find my current. So I'm going to do that. 6 is equal to whatever the current is times my 4, and I can find my current. So I just have to divide 6 by 4, which is 1.5, and I have my current. Excellent. So 1.5 is my total current. That is useful because when I go and look at this, I can see that all of that current has to pass through this resistor. So that means I can now say this is 1.5 amps as well. This now lets me use V equal IR to find this. So V equals 1.5 times 2.8. I'm not even going to bother to write that down because that's pretty much just easy. I can put that right in my calculator, multiply those two numbers, and I get 4.2 volts. Now, I'm well on my way. This is where a lot of people mess up, though. This is where a lot of people get confused because you have to remember when I got my 6 volts here, this is the amount of current per group of electrons, and a group of electrons is going to travel one route. So let's pretend it goes through this one and then it goes down and follows this route. So if we follow this red route, then the total should equal 6. So I've lost 4.2 here. That means I have 1.8 left, and all of that 1.8 ends up right there. If I followed a green route, the green route is the same. I lost 4.2 and then back around, and I would have lost my 1.8 here. If I followed my last route, which you'll notice goes out to the outer one, I'm still only going through 2 resistors, and the potential difference in those 2 has to add to the 6 because the 6 is the total per group, and the group's only going to take one path. So each path has to add to 6. That's what most people get confused on. Now it's really easy because I can find all of my missing currents, right? My missing currents are super easy because all I have to do is use V equals IR. So 1.8 divided by 6 will give me the amount of current in my first one up here at the top. And then if I look at this one, this will be 1.8 divided by 2, which will be 0.9. That's my second one. And then if I look at 1.8 divided by 6, again, same thing, I get my third one. And this will also confirm that I'm right, because if I take 0.9 and I add 0.3 and I add 0.3 again, what do I get? My total current of 1.5, because remember, it's just dividing into the 3 routes.